So in this last example, section 3.4, instead of being given two functions and calculating the composition of the two functions, we're going to do the opposite. We're going to be given a function and we're going to try to decompose it into two other simpler functions. So what I mean by this is you want to calculate, or you want to figure out, not calculate, but you want to obtain two functions. Maybe we can call one g and the other one f. So that when you process x through through g and then through f, what you end up in the end is something that's equivalent to h. So you could replace these two function machines by a single one called function h. Okay, and that would be h of x. Okay, so that's the idea here. So we know that h is, it takes x, and what it outputs is root of 5 minus x squared over x squared. So try to think about two functions, g and f, that would do the work of h. So to do this, one thing you want to do probably is look for a function g that's inside function h. And for example, inside the square root lies a function 5 minus x squared over x squared. So one possible answer, because there are many here, so this decomposition is not unique. Possible answers is that we first calculate this expression, so that would be our g of x, and then we feed that expression into a function, into the square root function. So possible answer is g of x would be 5 minus x squared over x squared. And then we take the square root of that. So this is the function square root that will do that. Okay? So this is what I meant by inside. You want your g to be something that's kind of going to replace x here in the formula for f. So you're looking for a function you can plug it inside another one. But that's not the only possible answer. One could actually say, hey, hang on, there's x squared. Okay? That you can feed into the function root of 5 minus x over x. In other words, replace x in the formula for f by x squared and you get h. So this is not, so I would say the first answer is the most obvious one. The second one is less obvious, but you can convince yourself that this is both are correct by doing f of g in both cases. And you are going to obtain the expression I have for h. Okay, in the same expression. There are cases you want to avoid because they're kind of boring. They're not producing anything useful. So one possibility is g of x is x, and then f of x is simply square root, the exact same thing as h. So this is not being very creative. You could also say g of x is the entire function h, which you feed to the identity function x that's basically doing nothing, like the input and the output are the same. So avoid these answers. I don't want them. So if I ask you to decompose and this is your answer, you're not going to get a lot of points. You're actually going to get 0. So I want something that decomposes h into simpler function. So maybe very quickly, I'll give you another one. If you've got h of x, which is x plus 1 squared, try to decompose that into two simpler functions. So once again, we look for a function that's inside another one. See this x plus 1, it's inside the function that squares things. So this is why we could say, oh, g is going to be x plus 1, and f is going to be the function that squares it. Okay, so that would be the most obvious answer here. And maybe just to, if I look back at my first example, maybe here a note for that first example, you could actually decompose a function into more than two functions, maybe three. If I go back to h of x, which is 5 minus x squared over x squared, I can actually, square rooted, I can decompose it into three functions. So I can say, actually, I take x, then I square, okay? And then after you, well, I mean, actually, I should put my little, you feed that into a machine that's going to square it, a function machine. You feed that into another function machine that's going to do 5 minus x squared over x squared. So here, that maybe you call that first function machine g, and then f. So g of x here would be just a function that squares. F of x would be the function that takes the input, subtract it from 5, and divide by the input again. And then you feed that into the square root function. Maybe I need another name. Let's call that m. So m of x would be the function that takes the square root of thing. So, and that would output 5 minus x squared over x squared. So this way you've decomposed h into three functions. So h of x here is g of x, then you do f of g of x, and then you do m of f of g of x. And then it's a decomposition into three functions. So h is m dot f dot g. So that's possible. This is something, again, that's super important in calculus, something that students really struggle with when they start calculus. They haven't seen it enough in Sec 5. So make sure you become good at this. Do all assigned problems and maybe more if you need to.